Hello, what do you have for lunch today? I had fish, some rice, and a good soya milk. But even though Singapore is renowned as a food lover's paradise, we should not take our food resources for granted. Did you know? More than 90% of our food here in Singapore is imported. This means that any disruption in the global food supply chain due to climate change, geopolitical developments, disease outbreaks, or export restrictions can hit us hard. That's why Singapore has set a 30 by 30 goal to produce 30% of our nutritional needs by 2030.
Currently, there are 110 coastal food fish farms and about 10 land-based food fish farms in Singapore. About 5,000 tons of food fish are produced annually, corresponding to 10% of the local fish consumption needs. For local food fish farms to produce more by 2030 to meet the 30 by 30 goal, reducing fish feed costs would be helpful, as it often accounts for about 60% of the total farm production costs. Hence, finding alternative feed ingredients from sustainable sources for fish meal replacement would be helpful as one of the ways of making aquaculture production sustainable.
Now imagine if we could turn waste into a resource. Remember that soy milk? The water discarded after soaking the soybeans is actually full of nutrients and microbes, a hidden treasure of economic and environmental value that we have been overlooking. Now we are harnessing this value through a circular bioeconomy approach, developing a sustainable way to recycle food processing wastewater into a high-quality aquaculture feed. This initiative, in collaboration with industry partners, a multi-institutional team, and the Singapore Food Agency, seeks to fully tap into Singapore's biotech innovation potential. Nutrient-rich used water supports microbial communities, which then transform nutrients into microbial protein, a perfect fit for fish feed.
After rigorous quality checks, our microbial protein is ready to be mixed into aquafeed formulations. We close the resource recycling loop by using the bioreactor effluent to grow microalgae. The remaining water is a valuable resource which can be reused by the industrial facility.
Feed making involves grinding and mixing different ingredients, including the microbial protein, pelletizing and drying before feeding to the fish. We then run feeding trials at the Aquaculture Innovation Center with two important fish species for Singapore's fish farming landscape, Asian seabass or barramundi and Pacific white-leg shrimp.
Our research shows that up to 50% of the fish meal in the diet can be replaced with the microbial protein without affecting fish growth performance. So microbial protein can be a sustainable alternative to fish meal.
Our research connects two industries and supports aquaculture growth, reduces CO2 emissions, and contributes to the Sustainable Development Goals and Singapore's Green Plan 2030.